Ukraine has more than 20,000 acoustic nodes, radar, thermal cameras, and people watching the sky. Yet even that network can detect a target and still not know what is flying. Ukraine's ePPO air defense app even has a button labeled UFO. No, it is not an alien alert. Observers use it when they cannot identify the target type. The help page even lists a satellite. In peacetime, that would be a curious puzzle. In war, it can be a decision made before the full picture arrives. One sensor hears an engine. A thermal camera sees a hotspot. Radar returns a brief track. But without reliable range, camera motion data, verified settings, and synchronized recordings, a few pixels can imply very different sizes, speeds, and target types. So why can more sensors produce better answers and more unknown contacts? We will follow the chain from first signal to the moment radar, acoustics, optics, and people build one picture. Remember, unknown does not mean alien, and it does not mean call everything a drone. It marks an honest boundary. The target is there. A reliable answer is not. This is no longer a rare problem for a lone observer. On March 24, 2026, Ukraine's Ministry of Defense reported 999 drones launched in one day. That shows the scale of the traffic. Every sound, flash, or radar return must be sorted quickly among hundreds of other signals. Ukraine is already training future officers to distinguish unmanned threats, choose electronic warfare tools, and work under visual and information overload. Here, unknown is not a dramatic mystery. It is where false confidence can be as dangerous as delay. If that difference between we see it and we know it matters to you, subscribe. This series separates strong facts from strong impressions. In May 2026, Combating Threats Exchange, or CTX, published a Ukrainian article on selected military observations from 2023 and 2024. CTX is peer-reviewed and hosted by the U.S. Naval Postgraduate School. But it is not an official Pentagon voice, and its conclusions belong to the authors. This is material for analysis, not government confirmation. The authors divide the process into stages: detection, a preliminary target type, identification with greater confidence, then a separate threat assessment. Sometimes action must begin before the target has a final name. The article says unusual contacts often get ordinary explanations: drones, balloons, lanterns, clouds, weapons effects, or other natural and human-made phenomena. Unknown describes what is known now. It promises nothing exotic and gives us no license to invent an answer. Take one example. The authors report that on December 24, 2024, objects appeared in a Mavic 3T thermal channel, but not in the paired normal camera image. That shows a difference between sensor channels, not invisibility, camouflage, or origin. According to the manufacturer, the Mavic 3T thermal module records 640 by 512 pixels at 30 frames per second. But an image does not reveal target range. Without range, pixels cannot be converted reliably into real-world size. Speed has the same problem. A nearby slow object and a distant fast one may move similarly across the frame. Add the drone's motion, camera angle, zoom, and compression, and one clip supports several stories. That is why NASA stresses calibration, metadata, baseline measurements, and independent sensors. NASA did not analyze these Ukrainian cases. The rule is broader. A striking image is not yet a reproducible result. The public article does not provide the full original files, telemetry, calibration, range assumptions, uncertainty bounds, environmental data, and chain of custody needed to reproduce every calculation. That does not mean the authors lack more material. It means the public record cannot reproduce every conclusion. The article also lists glare, optical distortion, frame defects, sensor problems, hardware processing, and software as possible sources of false strangeness. But the possibility of an artifact does not prove this contact was one. The honest answer remains: there is not enough data. If a few pixels no longer look like a ready-made conclusion, leave a like. Small checks often separate a measurement from a beautiful mistake. Back to the battlefield. Ukraine's Ministry of Defense says Shahed or Joran-type drones flying around 20 to 50 meters can challenge older radars. Terrain and the radar horizon hide low targets. Weak speed separation can blend them into clutter. A rotating antenna also updates the picture in sweeps, not continuously. The answer is not one perfect sensor, but a network. More than 20,000 acoustic nodes listen for engine and propeller signatures. Machine learning compares them with known types. Broad acoustic and radar coverage can cue nearby tactical radars and optical systems, giving a person or another sensor a second angle. This is not magic or a promise of perfect accuracy. Public material does not support that. It does show the principle. One sensor can cover part of another's weakness. Radar contributes a track, acoustics a sound signature, optics a shape, and a human the context. Together, they support a more responsible decision. Now the paradox has an answer. More sensors improve accuracy, but first reveal contacts the system never saw. Some quickly become drones, birds, satellites, clouds, or artifacts. Some need a second sensor. For some, public data may never be enough. The unknown need not become a miracle. Sometimes it stays a gap in the measurement chain. That chain is already changing. Ukraine has described an operational interceptor system that automates 95% of the cycle after an operator selects the target and commands the intercept. The key is not 95. It is where the human remains, target selection, and the decision to act. That leads to the next episode. When computer vision recognizes an object, an autonomous system plots a route, and electronic warfare distorts communications and navigation. Who and at what point must say, "Yes, that is the target. Tell us." During an attack, what is more dangerous, reacting too late or misclassifying the target? There is no simple choice. A strong system must not only answer, it must show how confident that answer is. The takeaway is simple. An unknown object is neither proof of something extraordinary nor a reason to mock the question. It is a test of data quality. Uncertainty shrinks through calibrated sensors, synchronized recordings, fused tracks, and people who understand the system's limits, not a louder theory or prettier image. The target may already be in the sky. An honest answer begins here. What do we actually know?